Good day, everyone across North America. This is Jason Metcalf with Sony's Professional Solutions, filling in today for John Garmendi. I would like to welcome you all to another in our series of Tech Tuesday AV Solutions webinars. These webinars were started in response to the COVID crisis so that our customers, resellers, integrators, and consultants can stay informed and up to date on Sony's latest products and solutions. Today's webinar is part of the Application and Technology Focus series during this month of August. This week will help you better understand and interpret projector specifications. We'll also take a look at some of the factors that may affect these attributes. Just a few items of housekeeping. With previous webinars, there will be an opportunity for Q&A, so please submit your questions via the GoToMeeting questions panel. I will post some links in the chat for information referenced during the webinar as well. And also we'll post a link to our YouTube playlist where you can view all of our prior Tech Tuesday presentations. Joining me today as our main presenter is Sander Phipps, Senior Product Manager for Sony's 4K Pro SXRD projectors. Sander, take it away.
Thanks, Jason, and thank everyone for joining us. I hope today you can find this to be useful. What we want to do a little bit is talk about projector specifications and what do they really mean, and to give you some numbers and some explanation behind the numbers so you can make an informed decision when you look at spec sheets. So joining us today is Jason and myself. Part of the Pro SXRD team. I have a little problem with my camera there, sorry about that. And like I said, we want to go through some of the numbers and talk about what the specifications really mean and how you can make a judgment of what is the right product for you. Sorry about that. So Jason is our sales support engineer for our Pro SXRD line, and I am the product manager and national account manager for our Pro SXRD line. So let's dive into this a little bit. What the specifications hopefully will do for you is to tell you what the projector can do, and probably more importantly, what it can't do, and will it do what I need it to do. There are a number of projectors on the market of various capabilities, price ranges, and definitely in the case of projectors, it is not one tool fits all jobs. So the idea is to find the right tool for the right application. Some things that should be considered is the application. What am I trying to do? Am I trying to entertain? Am I trying to inform? Am I trying to grab somebody's attention, create an environment? Basically just lecture, you know, what are we trying to accomplish with all this? And who is the audience? And probably the most important aspect of all of this is where is it going to go? What is the environment the projector will be at? Because the specifications can tell you what the projector can do and what they can't do, but they have to be taken into account with the environment that it will be used in. So the spec sheet that you see on the right actually is from one of our projectors. There are a lot of numbers on this. Some of them probably aren't all that straightforward. What does it mean? You know, what do I do with all these numbers? The specs I listed on the left are just a small portion of the numbers that are on the right, but they're probably the most important ones, and the ones that probably should be taken into account when making a decision on what's the right projector for you. So brightness seems simple enough. Brightness is how much light does the projector put out? Well, it is, but it's probably also not quite that simple. When you talk about brightness, you'll see specifications, something called an ANSI lumen. There's center brightness measurements. There's the ISO has a standard. The real question is what is the lumen and how many do I need? A lumen is a measurement of flux energy. It's a measurement of light energy, if you will. To give you an idea, a 60-watt incandescent light bulb is roughly 800 lumens, give or take. Something to keep in mind when you look at lumens and deciding what's the right projector and interpreting the specs is, typically speaking, a human eye can see or can't see or discern less than 100 lumen difference. So in other words, if I were to show you a projector that is 5,000 lumens and then show you a projector that's 5,100, more than likely you wouldn't see the difference. It's just nature of human response to light. The other thing to keep in mind, it seems obvious, but I don't know that people always take this into account. Parent brightness, or what the viewer or the human eye sees as brightness, will change based on screen size. So in other words, if I have a 5,000 lumen projector on a 120-inch diagonal screen, and then I show you the same projector on a 200-inch screen, it's going to look a lot dimmer because I'm spreading the same amount of energy out over a larger area. This is how an ANSI brightness spec is measured. ANSI, or the American National Standards Institute, got out of the business of doing projector specifications several years ago. I'm not sure why, but technically speaking, there is no such thing as an ANSI lumen anymore. The ISO, an International Standards Organization, took this over, but the measurement, the way it's measured and how you do it is exactly the same. You take a light meter and you measure reflective light off the screen over several points and you average it together. It's a very accurate, very fair way to do the measurement because you're looking at the entire screen. Probably more recently, there's been a move to, you'll see a spec called center brightness. Center brightness basically measures the light at the center of the image. Brightness across the breadth of the image will change somewhat based on the imager technology, based on the projector, based on the lens, based on a lot of things. Average brightness or ANSI brightness versus center brightness, one is not necessarily better than the other. One isn't trying to be misleading or anything else. It's just a different way to compare projectors. And especially if you're looking at a projector for a lecture hall that's doing PowerPoint and so forth, center brightness is probably a good comparison, honestly. Conversely, if I'm doing installations where there are multiple projectors blended together or things like that, you may want to look at the ISO brightness because that's probably going to give you a better comparison side by side in multiple projector installations. Other things that affect brightness: screen material, viewing angle, projection angle. When light hits a screen, and the screen's primary job in life is to reflect that light back towards the viewer's eye. But light's going to come, if the projector is tilted a lot, and the light is going to come in one angle and reflect back at another angle. In an ideal installation, that angle it reflects off the screen is coming back at the viewer's eye, but very rarely is there an ideal installation. So the point of this is, if you are looking at a projector and you think 5,000 lumens is good enough, it's going to be close, but that's probably adequate and so forth. You got to take into these other accounts because, yeah, it might be adequate on a perfect installation, but when you get into a real world installation, suddenly it's not quite adequate. And unfortunately, a lot of times by the time you get to that point to realize that, it's too late. So, you know, these kind of factors really, really, really need to be considered when doing a projector installation. Other factors around brightness: lens performance. Lensing is probably one of the most, from a manufacturer's point of view, one of the most difficult, expensive, precise parts of the projector. A lens is a very complex, a projector lens is a very complex device. This is a pretty simplistic diagram, but if you think about it, that light has to go through all those optical elements in a lens, and there is no such thing, no piece of glass, no magical material that will perfectly transmit light. So every time I go through a piece of lens, piece of glass, what have you, I'm going to lose a little bit of light. And especially on very short throw lenses and very long throw lenses, because there is more complex, thicker optics involved in those types of lenses. So lens shift and lens zoom position also will affect this. So again, back to that analogy, if I have a 5,000 lumen projector that I think is good enough, just makes it, well, it might just make it on a standard throw lens, but if I have to use a short throw lens, then suddenly maybe not. And I mentioned here up to 35% light loss. That's on fairly short throw lenses. That is not unheard of at all. Actually, it's fairly common. So again, keep that in mind when you're looking at the numbers. Other things, this actually was off of a particular, this is the same projector basically. This is one model projector that has all these different brightness specs. I guess I bring this up because you really have to look at this when you're trying to figure out what is the right model for you. One thing to keep in mind is something called fill factor. If I have in this case, a 1920 by 1080 projector, and I feed it 1920 by 1080 signal, that number of pixels, I will fill the entire imager and get probably the specified brightness. If I do what's known as a direct pixel map, and in this case feed the projector a 1920 by 1080, a 1920 by 1080 imager and feed it a 1280 by 720 image, I'm not necessarily filling the entire panel. The problem is the light is still filling the entire panel. So that dark area is all wasted light. So the same projector will not be quite as bright. And when you do a direct pixel map, and that should be considered as well. And then there's contrast. Contrast is probably, from a specification point of view, one of the most confusing, I don't want to say misrepresented because that's probably not fair, but probably the most abused specification because there are so many ways to measure it, so many considerations, so many things that affect it, that it is very hard from a manufacturer's point of view to put out specifications that tell the whole story, that help the person choosing the projector or looking at the projector to make the most intelligent decision. Contrast, in a nutshell, is the ability of the projector not to project light, if you want to think of it that way. It's a ratio, contrast ratio. It's a ratio to how dark the projector can be versus how light the projector can be, or how bright, if you want to think of it that way. All projectors, when they try to make a black image, with the exception of the old CRT projectors, I'm dating myself here, leak light and black. So if you turn the projector on, especially if the light's off, and look at the screen and feed it a full black signal, no image, you'll still see kind of a very, very dark gray area, if you will. That's the light leaking through the imagers or through the optics. Interesting thing about contrast is a high contrast projector will appear brighter. The human eye is very sensitive to that dynamic range, and it gives the projector, a lot of people refer to it as pop, if you will. It is much more visually pleasing to see a high contrast image. Contrast ratio, another way to think of it, is dynamic range. If you're an audiophile, audio equipment has a measurement that's typically called dynamic range. It's how well it reproduces a low frequency sound and how far or how wide a range of frequency it can reproduce. Contrast ratio is a visual ratio or a visual dynamic range, if you will. It's basically how dark can I go and how bright can I go. Thing to note is, there's a lot of talk and a lot of use, and a lot of people like HDR imagery. That's kind of one of the hot things in the industry now. You need a projector that has high contrast to show a high dynamic range signal properly, and I'll talk a little bit more about that in a minute. Like I mentioned, there's many ways to measure contrast. They all tell a story. They're all useful. I'm not going to say one is misleading over another, or it's some sort of game manufacturers play, because it's really not. What it boils down to is there are a lot of ways to measure it, and a lot of things, like I mentioned, that affect contrast. The imager type will affect it. The lens quality, again, will affect it. If you think about the checkerboard pattern up in the top right hand of the screen, if I'm On a monitor, that's very easy to reproduce accurately. On a projector, when I'm shining light through all these pieces of glass in the lens, some of that glass will take the white light and move it, bend it, diffract it, or spray it into the area of the black. So it affects contrast ratio. Screen type, and probably one of the things that's probably most abused is ambient light. If a projector is trying to project black, and there's a lot of white light from a window, from a ceiling light, whatever, hitting the screen, the screen's not going to be black because it's got white light hitting it. So you can have a contrast ratio of, a gazillion to 1, and if you have a lot of ambient light in the room, your on-screen contrast ratio won't even be close. On most cases, projectors typically will have contrast ratios listed, and they're typically measured in one of these 3 ways: native, on-screen, or dynamic. And native means basically what can the imager do? What can the optical engine reproduce from a contrast ratio point of view? And on the right-hand side are 2 diagrams, and I'm going to highlight, in the case of a DLP or a DMD chip and an LCD projector. In the case of the DLP, I'm taking little mirrors and bouncing light either through the lens to make a white pixel, or I'll move the mirror and bounce the light inside the projector cavity to make a dark pixel. Well, unfortunately, that light will spray around a little bit in the cavity, in the optics, and will get out even though I'm trying to make a black pixel. And in the case of LCD, I close all the little LCD crystals, and that shutters the LCD closed, and hopefully no light will get through it. Well, unfortunately, some light will get through the LCD crystals, and that's, it will affect contrast ratio. But that typically, when you see native, is talking about what the imager can do, and it doesn't take into effect room lighting, doesn't take into effect lensing, doesn't take into effect anything else but except the optical engine, if you will. The reason manufacturers use that is we don't know what lens you're going to use. We don't know which lens position you're going to use. We don't know anything else. So by giving you a native contrast ratio, you're making an apples to apples comparison. That's the point of that. Is it necessarily going to tell you everything you need to know when you install the projector? Probably not, honestly, but at least you have a benchmark to start with. On screen takes into account things like lensing and so forth. This is useful, but it's very hard for, like I said, for manufacturers to produce this number because we don't know where you're going to put it and how you're going to use it, and the angle which you're going to use it on, and everything else. And then there's dynamic. Dynamic means it changes. Basically is a method in which I will manipulate either the light energy or the image level going through the projector to match the scene content to enhance contrast. So in other words, if I'm watching a movie that has a very bright scene, I may take an iris and open up the light path a little bit more. Or conversely, a dark scene, I'll take the iris and close it down. Or I will take the image and drive the imagers a little bit harder for a very bright image, and conversely back off a little bit on a very dark image. Or maybe I'll do a combination of both. Dynamic contrast will give you higher numbers. And I go through all this because you'll see a spec sheet and you'll see one projector has 10,000 to 1 contrast ratio, another one has 1,000,000 to 1 of some crazy number. It doesn't mean they're different, it means they're measured in a different way. So you have to understand what you're looking at to make the right decision. Dynamic contrast is very good, and this goes back to deciding applications and how you're going to use the projector and where you're going to use it. Dynamic contrast is really good for video applications like home theater, like watching movies, because it enhances the viewing experience, and that's the whole point. It's probably not as good if I'm looking at content and making a decision about the content. I'm doing some kind of content creation, if you will, or I'm doing product design, or something along those lines, where I need to look at the content accurately to make a decision. Then, because dynamic contrast could be changing the image slightly, and you don't want that. Also, on multi-projector installations, like a blended image or a room that has showing the same image on on multiple projectors, that can create a problem too, because each projector may react slightly different to the image when it's in a dynamic mode, and that kind of creates a little bit of, you can see that, and that's a little disconcerting. So again, it depends on what you're doing, and as long as you're when you're comparing them, just make sure you're comparing the actual real numbers, if you will. Pixel count is, or resolution is pixel count. It's pretty straightforward. You know, there are a million different resolutions floating around now. 4K is the new buzzword. 8K is on the horizon. Couple things about resolution specs. There's what's known as native. Native is how many little individual pixels does the imager in the projector have. If it's a DLP device, then how many micro mirrors does it have? If it's a LCD type device, how many little pixel crystal windows does it have? Another technology that's in use today is something called E-shift, and it's a digital manipulation to show more pixels than the native resolution or the native imager has, if you will. The point of E-shift is the higher the resolution the imager, typically it is more expensive to make, and in some cases is bigger. It has to be larger. So E-shift is kind of a way around that. There's a lot of terms for it. E-shift, pixel shift, wobulation. There's a lot of ways you can describe it, and they work slightly differently, but they're basically behind it all is essentially the same idea, where I take a high resolution signal and break it apart and show it faster, if you will, at a high frame rate, sort of like the way 3D works, where I would show left eye and right eye, and then your brain puts the two signals back together. Because it's doing this at a higher frame rate, in most cases, you are limited to a 60 hertz input signal, which is something to keep in mind, because 120 hertz imagery, especially for anything that has movement in it, is becoming much more popular and probably will become much more prevalent over the coming years. So that is one thing to keep in mind. This slide kind of, I guess, is graphically, if you will, sort of shows how this works. I take a UHD signal and I break it into two HD signals and write it twice as fast. So the image of each HD signal is on the screen for 1/20th of a second. And then I show the other half. So every 60th of a second, I'm seeing essentially 2 frames of slightly shifted image. It actually works pretty well. Like I said, there's a limitation of high frame rate. Things with a lot of motion and a lot of detail, it may create some artifacts. That's, it's a kind of a compromise. Typically, these are less expensive and easier to make, but there are some trade-offs. So, other things around resolution, the pixel size, and how much you can see the pixels or how smooth the image is will give you what appears to be a higher resolution than is actually there, if you want to think of it that way. Or another way to think of it is the smaller the pixels and the less infrastructure or cell gaps around them, projector looks smoother. You're getting more pixels in a smaller area, and your apparent resolution to your brain seems higher. Another interesting thing is contrast ratio. These are 2 very crude drawings, but essentially they are the same resolution, if you want to think of it that way. But the black-white versus gray-white looks much sharper, and some people would say that looks like a higher resolution signal because of sharpness, if you will, of that. I mentioned 120 hertz. There have been a lot of studies over the past few years regarding 120 hertz. The human eye likes the higher frame rate. It perceives that as being higher resolution or more information. It's a challenge from an infrastructure point of view, but if you have applications that have any kind of high-speed movement, 120 hertz is a nice feature to have, and you may want to keep that in mind. And then there's HDR, high dynamic range. High dynamic range gives you the ability, or an HDR signal gives you the ability to get more detail in parts of the scene or parts of the image that typically you couldn't get before. You know, the classic example is details in very dark scenes and very bright scenes. This is the reason I talk about contrast ratio being dynamic range. Well, HDR is high dynamic range, or in other words, HDR is really a high contrast signal, if you want to think of it that way. I'm not going to go through all of this, but basically, it is a change in the algorithms that the camera or whatever device creates the image to take light energy and turn it into electrical energy. And that change in the algorithm is a metadata that rides along with the signal that tells the display device what algorithm it used so it can reconstruct it accurately. HDR is, you know, wildly popular these days. You know, everyone's TV talks about it. If you go on Netflix, you'll see that, you know, a lot of the content is HDR created now. It definitely feeds that need for the resolution or that image pop that viewers typically are drawn to. The takeaway here is, if a device can say it accepts an HDR signal, so in other words, it can read that metadata and decode it properly, but if it doesn't have the native contrast, it doesn't have the ability to resolve this wide dynamic range, you're really not getting the full benefit of HDR. So if HDR is important, the first thing I would do is look at the actual real contrast ratio of the display device, then will tell you which way to go. Color measurements. You'll see a lot of specifications on spec sheets, cut sheets about color measurements, color temperature, space, color gamut. Unlike lumens, by the way, the human eye is incredibly sensitive to the very subtle shades of color difference. So the ability to reproduce wide color and accurately reproduce it is very important. I talk about the math behind this, but long story short is like I said, humans are very, very sensitive to this. So, and are very drawn to vibrant, rich, wide color space, if you will. So talking about that, you'll see spec sheets that talk about color temperature. Color temperature means what color white do you want? Go to Home Depot and pick out white paint. There are a gazillion shades of white. What does it mean? Typically, they're measured in, you'll see D65 or 6500, which is a little bit, I don't know, redder, if you will, and then D90, D9300, or other numbers like that. Basically, the higher the number, the more blue it is what it boils down to. The lower the number, the more reddish, oranges, I guess you would say, it goes to. What it really comes down to is this is what the definition is. There was an experiment done, I think it's over 150 years ago now, where someone would heat a piece of metal, I think it's tungsten, and depending on what degrees Kelvin it glowed at, would determine the color temperature. So if you heat this metal up to D9300 or 9300 degrees Kelvin, it will turn blue. As opposed to 6500, it would be a little bit more reddish. That's what the number means. That's where it comes from. You know, if you ever have a bar bet, there you go. That's what that's about. Color space, on the other hand, is a map, if you will, of what color ranges I want to reproduce. You'll see up in the right-hand side these different triangles and different color spaces. It's not necessarily saying this particular display device will project all of that particular area. What it's saying is it will accept and recognize these color spaces, sRGB, you know, Rec 709, what have you. This is useful to know that if the projector has the brains, if you will, to decode different color spaces so they can represent accurate hues and shades. On the other hand, color gamut is how well a projector or a display device can fill that particular color space. Color gamut is actually probably a better, more useful specification in color space. Color gamut is telling me, okay, if I have a D6500 color space or a Rec 709 color space, and I can fill 100% of it, that means I have all of that volume of color I can reproduce. The larger the color gamut, the more vibrant the image, the more engaging, the more capturing, so forth. From a display point of view, it's much harder to make a wider color gamut. There's just more involved. There's more information at the process. There's more wider, broader spectrum of light output I need. It's a more difficult challenge to do. This is kind of an indication. This is what a large color gamut gives you. Gives you pop, gives you, like I said, an engaging signal. So I guess from my point of view, the takeaways I would like people to kind of get from this would be the specs on a projector can tell you a lot, but they can cause a lot of confusion. There's so many numbers out there. There's so many different ways to measure those numbers. In a lot of cases, we get, as a manufacturer, a lot of questions consistently. Why does your spec say this versus so-and-so spec say that? It doesn't mean one is inaccurate or one is misleading or anything else. It's not that. It is, we're measuring it this way. Other people are measuring it that way. In a lot of cases, it's because of the application the projector is intended to be used in. As well as when people look at projectors, typically they'll look at brightness, price, and then maybe contrast ratio. And I think rarely they go much past that. And that's probably okay if you're going to hang a projector, I guess, in maybe a simple classroom and you're going to show PowerPoint. If you're doing a lot more than that, you're probably doing an injustice by simply looking at those numbers, because there's a whole lot more going on there. And then, the other part of the equation is good-looking numbers don't mean a good-looking image. There's a lot more going on here, and you really need to take the numbers into account based on how or what you're doing and where you're putting it, not just looking at the numbers. So with that, I think that's the end of my presentation. So I guess we would go to our questions at this. I should mention next week, our next installment of Tech Tuesday will be PCs in the Office of the Future. So please attend that. And there's some QR codes and some links there for a lot of good information about our projector lineup. So with that, Jason, I think we're ready for questions.
Thank you, Sander. We do have a couple questions from the audience. Dawn asks, what is the difference between Rec 2020 and DCI P3 color space?
That's actually a good question. DCI P3 color space is a subset of what's known as REC, or Recommended Standard 2020. Recommended Standard 2020 was a color space that came out several years ago. The idea being, with technologies like RGB laser projectors and other technologies coming, that a wider, more vibrant color space could be created. And the Rec 2020 actually challenges the entire breadth of what a human eye can see. P3 is a subset of that actually, at this point, is what technology can reproduce accurately and faithfully. So it's not quite the full range of 2020.
All right. Catherine asks, does Sony use wobulation?
No, we do not. We are a native imager kind of folks. For our high resolution projectors, our SXRD projectors, we use obviously SXRD chips, which are a little bit easier to make a high resolution image or high resolution imager and a smaller imager than some other technologies. So for us, we decided to stay with native resolutions.
All right. Terrence asks, how do you see projection image quality standards evolving over the next 3 to 5 years?
The biggest changes probably will be the continual development of the light source. From a projector point of view, the image, the brightness, and the amount of color gamut it can reproduce, if you will, or the amount of color range, is directly proportional to whatever light source you're using. You used to use lamps, laser phosphor, RGB laser, LED technologies. They all will probably undoubtedly actually get better, which means a brighter image, and also probably, much easier obtain wide color gamut.
All right, thank you. Greg asks, does Sony use the same standard of measurements for all projectors for light levels?
Yeah, I mean, you'll see on some of our specifications, center brightness and ISO brightness. Some you'll just see, especially I think more on the home theater side, different measurements. And that goes back to where you're going to use the projector. For instance, dynamic contrast is incredibly important in home theater because you're watching movies, and as I mentioned, dynamic contrast really enhances the viewer's experience. So we'll use that specification a lot on the home theater side. Typically on the pro side, we tend to use the native contrast ratio. And in fact, you could get two wildly different specifications, native versus dynamic, on the exact same projector. That doesn't mean one measurement is inaccurate. It's just the way we're measuring it and the application we're looking at when we measure that.
Yeah, awesome. Thank you, Sander. That seems to be the end of the questions. I did want to thank everyone for attending. As Sander said, please do join us next Tuesday for our presentation on these future office technologies, including these IP connected devices. Also be aware that when this webinar ends, there is a short exit survey that will pop up. We do appreciate your feedback so we can continue to improve these presentations. I wanted to thank you all again for joining us, and I hope you all have a great rest of your day. Thank you.
Thank you.